Okay, let's begin the third part of the theory of functions unit. The next thing is composite functions. As I said before, you'll be getting my notes, but I'm just going to take notes. So let's look at an introduction problem, and the idea is you work in sales, so you work in sales, and you make 5% on all sales after the first $1,000. Okay, so the first question, if sales for this month are 13,500, how much will commission be based on? How much will commission be based on? Right? So, and then the second question is obviously, what is the commission? What is your commission? So, the first part, let's think about it. What is the first part? Well, you say, well, no, do I take 5% of 13,500? And you say, no. First, I have to take 13,500 and subtract 1,000. So 12,500 is what my commission is based on. Then, second, I take 5% of 12,500. Did you see what I did there? 5% of 12,500, and your commission for the month is $625. So the commission based on sales is equal to S minus 1,000 times 0.05. And this is the idea of the composite functions, that there's an input becomes an output, and then that becomes a new input, and that becomes a new output. So let's take a look at this. So the first thing we're doing is we're taking the sales and we're subtracting 1,000, and then we're taking that sales minus 1,000 and multiplying it by 0.05. Now, from a function's point of view, once again, like this was the x that became the y, but now this becomes the new x that becomes the new y. Or, x1 goes to y1, and x2 goes to y2. So a composite function, so let's see, a composite function, right? And it's denoted as that, or this, and it's read as, so it is a series of operations, and it's read as, we say, f of g of x. Okay. Now, the idea is you're going to be given two unique functions. You're going to say, what is f of g of x, or f of g of 2? So let's do one example. So let's say f of x is 3x minus 5. And let's set g of x equal, what do I have it as? X squared plus 2x minus 1. X squared plus 2x minus 1. And so the first question might be, what is f of g of 2? And so the first, we work inside and we work out. So we take the 2 and put it in the g function. So, someone out there? No. G of 2 is equal to 2 squared plus 2 times 2 minus 1, which is equal to 4 plus 4 minus 1 is 7. Then we take the 7 and put it in the f function, which is f of 7 is 3 times 7 minus 5, which is 16. So f of g of 2 is 16. Once again, so we're starting with 2. We're mapping it through the g function, which takes us to 7. And then we're mapping 7 through the f function, which takes us to 16. Yes. Let's try another example. So we're gonna keep the f and the g's the same. We're gonna keep the f and the g's the same. So, for example, how about I say g? How about let's see, g of f of negative 3. Okay, that's fine. Once again, we start with the f function. So f of negative 3 is 3 times negative 3 minus 5, and that's negative 14. And then g of negative 14 is, what do we have? Negative 14 squared, plus 2 times negative 14 minus 1. Let's see, 19 times 19 is 196. Minus 28 minus 1. What is that? Hey Siri. 196 minus 28 minus 1.
196 minus 28 minus 1 is 167.
167. So we say that g of f of negative 3 is 167. Let's just take us through the mappings again. We started off with negative 3. This time the f function, because the f was the first thing, f took negative 3 to negative 14, and then we worked our way out. The g function took negative 14 to 167. Now, the idea is, so the question is, what if I just ask you, what is f of g of x? Because maybe I don't want to calculate over and over. I just want a new formula. Well, the idea is this g function, whatever's here, goes into the f. So in this case, the f function is 3, open parentheses, minus 5. Well, we're putting the g function inside of there. Once again, the g is inside the f. The g is inside the f. Final answer, 3x squared plus 6x minus 8. What about g of f of x? No big deal. We're putting the f inside the g. Well, the g is something squared plus 2 times something minus 1. The f is 3x minus 5, right? 3x minus 5. Well, it's a little work. Let's see, we can do this. Or you can speed it up quickly. What do we have? We have 9x squared minus 30x plus 25. You need to know how to do this. Plus 6x minus 10 minus 1. Final answer, 9x squared minus 24x minus 14. Just a little thing. You know what? Can we do f of x? Is that possible? Yeah, we're just putting an x value through the f, and then we're taking that value and putting it back in the f. So, for example, if I say f of 5, you say, fine, first, f of 5 is equal to 3 times 5 minus 5, which is 10. And then the next thing we do is take f of 10. 3 times 10 minus 5 equals 25. And the same idea here. We're putting f inside of f. we're putting f inside of f. Final answer, 9x minus 20. Let's move on. The next thing is we want to see what happens with the domain and the range when we do these composites. So for example, if I have f of x equals radical x, and we have g of x is equal to x squared plus 3, so you might be asked, what's g of f of x? So you say, no big deal, I'm putting f inside of g. Fine. Here's my g, and I'm putting f inside of it. And so we have x plus 3, radical x. Okay. So what's the domain here? So what's the domain? What is the domain? Right? And so you look at this and you say, oh, well, you know what? I can't put negative numbers underneath the radical. So the domain is x is greater than or equal to 0. Okay. Well, what's going on here? How about if I ask you f of g of x? You say, no problem, Mr. Eiler. I'm putting g inside of f. F is radical on radical x, and I'm putting g inside of it, x squared plus 3x. Well, what's the domain here? Well, you'd say, I'm not sure what's going on here, but I do know that anything under the radical has to be greater than or equal to 0. So I have x squared plus 3x is greater than or equal to 0. This technically is the domain, but obviously IB wants you to figure out the exact x values. Well, that's not so difficult. You can use a sketch. You have a couple of choices here. First of all, I factor this out. And then first of all, when is it equal to 0? Well, you know that if x is negative 3 and x is 0, these are two cases where it equals 0. The question is, I need to be above 0. Well, the easiest thing to do is look at this sign chart I made, just test some values. So for example, if I use negative 10, well, negative 10 and negative 7 is positive. If I use negative 1 and positive 2, this is negative and this is positive. An easier way I tell the kids to do this is just, you know that this is a parabola that looks like this. And so the domain, so where is it? Where's the x values positive? Well, we know that's here and here. So the domain is x is less than or equal to 3, or x is greater than or equal to 7. We'll talk more about this another time. Let's move on. And so the question is, why aren't the domains the same? Are these domains the same? No, because No, because the inside functions are different. So are the domains the same? Are the domains the same? And the answer is no, because the inside functions domains are different. Now, just a little thing before we get to it. If you notice, f of g of x and g of x are not the same. Therefore, they're not equal. If you switch them around, they change. Just an important note. Composition of functions are not commutative. You can't switch it around. So for example, commutative, I mean, A plus B equals B plus A, or, A times B equals B times A, that's fine. But this, you can't switch them around. You don't get the same thing. We can also do composite functions with ordered pairs, diagrams, and graph. So let's move on. Composite functions from ordered pairs, diagrams, or graphs. So for example, if I tell you that f of x equals 1, 2, 5, 8, and 6, 9, and I tell you that g of x is equal to 8, 11, 2, 7, and let's see, 9, 1, you might ask me, what is g of f of 5? And once again, you don't have a chart, you don't have a formula, but you do have a set of points. So first of all, what's f of 5? You say that's 8, and then g of 8, that is 11. So the answer is 11. Let me show you a picture. Let's see, what are we looking at? So the next thing is, take a look at this, take a picture of this graph. Ready? Let's see. Take a picture, take a picture, take a picture. So the question is, what is f of g? So f of g of 2. Oh, there we go. So let's see. F of g of 2. Well, the first thing is you're going to find g of 2. Well, if we look at the graph, g is the green. At 2, it's what is that? G of 2 is 3. And then from the graph, what is f of 3? You can look at the graph. We look at f of 3. And we see that it is about 3 also. Nice. Let's take a look at the next example. G of f of negative 1. Let's see. G of f of negative 1. Okay, so I want to find f of negative 1. Let's go to the graph. F of negative 1. That's kind of like that's 1 also. And then what's g of 1? Okay, let's see. Once again, the g is the green. 1, that's about 3 or 2.5. And then the last thing I want to know is g of 0. G of 0. Okay, well, where does the green at 0? The green is at 2. So g of 0 is 2. And what's g of 2? Because we're putting it back in the composite again. G of 2 is 3. Let's see. Question. A life insurance company offers insurance based on age. Question. A life insurance company offers insurance based on age. Okay, and the formula is the cost, C of n is equal to 1.25 times 2017 minus n. Now, assume this book was written in 2017. So you know what? Let's change it to 2021. Well, no, because... No, we're good. No, 2021. So, sorry, yeah, we're good, 2021. So the question is, so what is n is the year a person was born. Okay, and then C of n is the dollars in cost, yes, costs in dollars. Sorry. So C of N is the cost in dollars. Okay, so the first one, decompose the formula into two functions. So part one, decompose the formula into two functions. So what's going on? What's going on? Well, the first thing is this age, this 20 minus 21 minus n. Let's call that A. And then what's the next part? The cost seems to be A times 1.21. What do each of these represents? That's part B. So part B, what do these represent? What do these represent? Well, the A is the age of the person. And what does the second formula represent? The cost of the policy. Nice. Let's say, example, let's say that someone was born in 1968. Let's see. Part C. Let's see. So first of all, part one, what is the age if a person was born in 1968? And then the last part, what were their premium? Part one, part two, what will their premium be? So let's figure that out. Well, what are we going to do? Well, the ages, what's the age? Okay. Well, we know it's 2021 minus 1968. What's that? 32, 53. Last, what will their premium be? Well, 53 times 1.25. Hey Siri, 53 times 1.25.
53 times 1.25 is 66.25.
$66.25 a month. Next and last question. Sorry. What year was a person born if their premium is $41.25? Let's see. D. What year was a person born if their premium is $41.25? What do you think? Think about that. Okay, we're back. Well, we can work backwards. We can say the age is equal to, I'm sorry. The cost was equal to the age times 1.25. So we know that 41.25 equals A times 1.25. Divide both sides by 1.25. Let's see. Hey Siri, 41.25 divided by 1.25. Hey Siri, 41.25 divided by 1.25.
41.25 divided by 1.25 is 33.
33. And so the last part is what year were they born in? Well, we know that it's the year. So we know that it's 33 is equal to 2021 minus n, right? Well, I know that n is equal to 2021 minus 33. Hey Siri, 2021 minus 33.
2021 minus 33 is 1,988.
1988. Good.